Okay, guys, we're on the back side of some extra word problems for our exponential formulas. And number 7 says that a teenager made $712 working all summer. They have two options offered at their bank. Option A offers a 5.3% compounded continuously for the next 6 years. Oops. Option B offers a rate of 6.0% compounded quarterly for the next 5 years. Okay. They said write a function A of t and B of t for both option A and option B in terms of time, which is t in years. Okay, so in the first one for option A, they want us to use A of t, but yeah, we can do that. Okay. But for option A, keep in mind that option A said compounded continuously. So I'm going to write down the formula first. So it's A of t equals P e to the RT. Remember, if you want continuously great looking hair, use per shampoo. Okay, so you use your formula. And so this one's going to stay A of t. Your P, which is what you're putting in, is $712. E, and then raised to the R. R is your rate, and for option A, that's a 0.053. And then we are, we don't have, for 6 years, but they want us to just use T for right now. So times T would be 0.053 T. Okay. For option B, they want us to use B of T equals, okay. However, this one's for compounding quarterly for option B. And so that's a different formula. That's our P in parentheses 1 plus R divided by N raised to the NT. So we'll keep this as B of T. Okay. Our P value is still 712. Still what we're putting in, and then this would be 1 plus our rate. Now our rate for option B, be careful, it's different. It's 0.06 divided by our N. Quarterly refers to the number 4. So we'll divide by 4, close it, and then raise it to the 4. And again, they wanted us to just use a T for right now. I know it says 5 years, but we're just writing a formula or a function. Okay, and so those are the formulas or the functions that we're going to use. And now in the second part where it says which option will yield the most money. And now we're going to go ahead and plug in. So in option A, they have our T value being 6 years. So we're going to say A of T, or you could say A of 6, or you could say Y equals, it doesn't matter. Okay. We're multiplying that by 6. Okay? We're just going to go ahead and type it into our calculator. And we end up with 978.5558 ... Okay? And then for our B of T, we have everything the same here, except our T in option B is 5 years. So we're going to multiply this by 5. All right, we're going to go ahead and type it in. And we end up with 958.9607 ... Now I could round those because they are both money. However, the question wasn't really about how much more money. It's just which one has the most money. So I don't really need to round them. My answer is either A or B, and who has the most money is option A. So option A will yield the most money. All right, so that one's done. All right, let's take a look at number 8. And in number 8, we're talking about potassium 42. And has a half-life. And so there is the keyword that tells us what formula we should be using. Okay. And it has a half-life of 0.4 hours, how much to the nearest hundredth, which is our rounding directions, of an 848 gram sample of potassium 42 will be left over after 4 days. 4 days. Okay. So the keyword half-life is going to tell us to use our half-life formula, and that is A of T. Equals A sub 0 in parentheses 0.5 raised to the T divided by H. Okay, so in there we have A of T, we have A sub 0, we have T, and we have H. All right, so potassium has a half-life of 12.4, so that's lowercase. That's our time, but it's the half-life time, and so it has to go in for lowercase h, not our T. And this is in hours because we have to make sure that those labels on there, those units are the same for T and H. Okay. It says that we have 848 grams to be starting with. And we want to see how much is left after 4 days. And you guys are going to see right there that we have a little bit of an issue. Our T and our H are not in the same units. I don't believe that we can change a half-life increment of 12.4 hours. So I think we're going to have to go ahead and change our 4 days to be in hours. And if you know, guys, that there are 24 hours in one day, and so 24 hours in one day, 48 hours in 2 days. So you can see it's a multiplication. So 24 times 4 is going to change that into 96 hours. Okay. All right, so let's go ahead and now plug in that we are confident that we have our information correct. So we're going to have A of T, or you could have A of 96 if you wanted to, equal to our A sub 0, which is 848.5 in parentheses, and then raised to the 96 divided by 12.4. We'll go ahead and type that in. Older calculators, make sure your 96 divided by 12.4 and your exponent is in one set of parentheses. And we should end up with 3.9613, And our rounding directions were to the nearest hundredth. Nearest hundredth is the second spot. Look next door, and we're going to go ahead and say that we will have 3.96 grams left after 4 days or 96 hours. Okay, awesome. All right, we have 2 more questions to do. Oops. And in number 9, it's talking about a population of fruit flies. And so we have 50 fruit flies. And they said that they're increasing at a rate of 6% per day. How many fruit flies will there be in 3 weeks? What formula are we going to use? I don't believe we read the word compounded or continuously, or we did not read half-life. And so we're going to go back to using our first formula, y equals AB to the x. We'll write down our A, B, and x. And we have a population of 50 fruit flies. I believe that's our initial amount. They are increasing, so 1 plus 0.06. Okay. And they want to know how many fruit flies will there be in 3 weeks. And I'm not sure if you guys catch that, but we have weeks and days. Okay. We can't change our percent because that's 6% per day, but we can change our 3 weeks, okay, to days. So how many days is in 3 weeks? Remember, 7 days in a week. 7 times 3 would be 21 days. All right, a little bit tricky with that conversion. And we're solving for our y. So we're ready to plug in. And we're going to go ahead and say y equals 50, 1.06, and raised to the 21st power. And if we type it in, we end up with 169.97818 dot, dot, dot. And I didn't see any rounding directions. However, talking about fruit flies, I don't think we can have a decimal of a fruit fly. And so we're going to go ahead and underline the whole number spot, look next door, and that 9's going to round that 9 up, and that 9's going to round the 6 up. And so we're going to go ahead and say 170 fruit flies. Okay. All right. And last one, guys. It says that a store had 1,250 goldfish on day 1. All right. And then it says by day 9, they had 326 goldfish. And it says assuming an exponential decay, because if you notice, the number of goldfish go down over the days, determine the percent rate of change to the nearest tenth of a percent. Okay. Again, guys, I don't think I read the word compounding. I don't really think I read the word continuously, and I don't think I read the word half-life. So I'm going to go ahead, guys, and say that this is y equals ab to the x, our first formula that we learned. And remember, guys, that in this formula, the tough part that people screw up is that the b value, guys, either has to be 1 plus your rate or 1 minus your rate to be growth or decay. Okay. And so it says a store had 1,250 goldfish on day 1. That is the initial amount that we're starting with, which is our a value. And they finally had 326 goldfish by day 9. Okay. 9 minus 1, guys, is 8 days. And so that is our time frame. And it is decay, so 1 minus our r. And the r is what we are solving for. So this is one of those work backwards ones. Okay. If we go ahead and plug in, we have 326 equal to 1,250 in parentheses 1 minus r and raised to the 8th power. Okay. This is the one, guys, where we have to remember to isolate the exponent and what is on before we can free out that r that's guarded in those parentheses. Okay. And so we are going to have our first move be to divide by 1250. And we're going to go ahead and end up with 0.2608 dot, dot, dot. Again, guys, I'm not rounding. Not yet. Not till the end. Okay. And now, guys, I am ready to go ahead and use my reciprocal power to get rid of that 8 exponent. On this side, guys, when I type it in, I get a 0.84535 dot, dot, dot equal to a 1 minus r. I'm going to go ahead and subtract 1 to get rid of that 1. And I am left with a negative 0.15464 equal to a negative r. Okay, 2 ways to get rid of the negative on the r, guys. You can multiply by -1 or you could divide by -1. I usually divide by -1, which really just makes everything positive. All right, so we end up with r equals 0.15464 dot, dot, dot. Remember, guys, that we have to make it into a percent by moving the decimal. And so now it's going to be 15.464 dot, 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 but now it's a percent. And they told me to the nearest tenth, which is the first decimal, but look next door. And we end up with r equals 15.5%. And that is the rate of decay, or a rate of the decrease in our poor little goldfish. All right, guys, hopefully that helps once the problems are mixed and what formula to use and what the variables stand for and how to round. All right, that is a good worksheet to review and make sure that you know how to do all that. All right, guys, I will see you on the next day of notes.